This is a video on a learning map I have done for P2, and it's P2 Part 1, Forces and Motions, AQA. So you need to know the different types of forces. Right, first of all, whenever you have an arrow, we're generally representing a force, okay? And then you'll have a numerical value in newtons either side. Force is actually mass times acceleration. That can come up. Acceleration is meters per second squared, mass in kilograms, force in newtons. So the different types of forces we got. We have gravity. Most people know that gravity is a force. Magnetism is a force, however, it is more, it doesn't come up in P2, it comes up in P3. Friction is a force when you have two objects against each other and then moving in opposing directions. It will generate friction, which generates heat as well. Weight is a force. Everyone forgets this. When you say I weigh this, you're actually lying. What you mean my mass is this, if it's followed by stones or kilograms. Your weight is the effect that the gravitational pull of the planet that you're on has on your mass. So weight is actually measured in newtons. Thrust is a forward propulsion force, so anything moving forwards. Upthrust, or sometimes called reaction force, is when you have anything on a surface, that because of equal and opposite reactions, that is also pushing back with equal strength. Air resistance is when anything's moving through air. The quicker you go, the more air resistance. Also, it's affected by the surface area of the object hitting the air. Tension is also a force. When two things are pulling on, say, a rope or something. Now, this is really important. Measured in newtons, capital N. Newtons, newtons, newtons. I can't say it enough. They quite often ask you to write it down for 1 mark. Resultant force is the forward force minus the backwards force. I always refer to it to my classes as a tug of war. So imagine you had, say here, 200 people pulling you this way, 50 people pulling you this way, and if they all had equal strength per person, you're going to go this way. So it would be 200 minus 50, so it'd be a resultant force of 150 newtons, okay? The thing about resultant force, if you have a resultant force that's greater than 0 or even minus, they're going to be accelerating, okay? So resultant force bigger than 0 equals acceleration. So you have here, this car will be accelerating this way. If the resultant force, though, is 0, it means that the object is either stationary or moving at constant speed. So, for example, if here that was 50 and this was 50, that would be a constant speed because they have a forward force, thrust, and they have a frictional force going backwards. If, however, it was, say, an upthrust and weight, and this was 200 going down and 200 going up, that would then be stationary. So that's how you know. Stopping distance came up last year, so whether it will again, I don't know. But stopping distance is equal to thinking distance plus braking distance. Now, you sometimes ask to define these, and people get it wrong. Okay, so thinking distance is a distance you travel in the time it takes to think about stopping or think about applying the brakes. Braking distance is the distance travelled under braking force until you come to a stop. Don't put the time taken. It's not the time. It's nothing to do with the time. It's to do with the distance. Different factors that can affect these for thinking distance is anything to do really with the person. Speed is for both, but alcohol can impair your ability to think. So can distractions such as mobile phones, music, children. Alcohol, drugs can also affect your, and it isn't just the legal drugs, it can be prescription drugs. You might look on the back of them and say, warning may cause drowsiness, you shouldn't really drive if you're taking those, things like hay fever tablets and stuff. And also being tired can affect your ability to think straight. Braking factors, speed again, is anything to do with the car or the road conditions, so brake pads, the tyres being baldy, or the weather or the road surface. Okay, we have 2 different types of graphs here. I have got a separate video on those. But last year, velocity time graphs didn't come up at all, so I have a feeling that they might come up. You've got your velocity and your time. So if you have a velocity changing in a set time, this is equal to acceleration. So the gradient of the graph equals acceleration. I can see here maybe that this is a steeper or faster acceleration than this one because it's got slightly steeper gradient. When you have a horizontal line on a velocity time graph, this means it's going at a constant velocity, okay? Time is passing, but they're still doing a certain velocity, so it isn't stationary, it is a constant velocity. A downward slope on one of these graphs would equal deceleration. Okay, so you can have it as a negative value because your final velocity would be 0, minus your initial velocity, you see, divided by the time taken. Now on here, it might ask you to work out the distance travelled by the object. This is equal to the area under the graph, okay? A lot of people forget this. So if it was a triangle, you just work half times base times height. If it was a rectangle, you just go length times width. It's exactly the same. They could relate these to a terminal velocity, okay? So a parachutist, and they could relate to forces. So you need to know about the weight of the parachutist and the air resistance. So for example, if it was here, they'd be jumping out of the plane, they'd be accelerating, terminal velocity, things like this, okay? So both velocity and speed are measured in meters per second. Speed, though, is distance covered in a set time. It isn't a vector, it doesn't have a direction, whereas velocity is speed in a given direction. Distance time graphs are quite simple ones. One came up last year. You've got distance travelled in a set time. Gradient of the graph here equals speed. However, when you have a horizontal line, it means that time is passing but no further distance is gained, therefore they must be stationary. You wouldn't or shouldn't get a downward line on these, because then that would become a displacement time graph, not a distance time graph. Acceleration is change in velocity. That could be speed or direction, because velocity is speed and a direction. So it would be acceleration equals the final velocity, which is v, minus the initial velocity, which is u, divided by time. So these v and u's are measured in meters per second. Time is in seconds, so acceleration is meters per second squared. If they ask you to work out acceleration, they will ask you to remember that, because everyone forgets it. Work done. There's also a video on this separately. Work done is equal to energy transferred, okay? That could be either lifting an object against gravity or moving an object against friction. You're doing work in both of those. Work done is equal to the force times the distance, okay? So force in newtons times the distance in meters. Work done is in energy, so it's measured in joules. They may also then relate this to power, because power is the rate of which you do work at, okay? So again, in here though, they don't put it as the work done as W, they're a bit crafty. They have it as E, because you have just worked out energy transferred. So if you had one of these questions and it was followed by a power question, you just put in whatever answer you worked out there as your E here. So it'd be power in watts equals energy transferred divided by time taken, which would be in seconds also. Momentum, when they come up, can be with questions. One came up near the end of the paper last year, so whether they put it on again, I don't know. If people did badly, they might do. People find it quite difficult. Momentum is the strength of a moving body, okay? Now you work this out by the mass of the object times the velocity that they're going. So momentum is measured in kilogram meters per second. Now the rule you need to remember for momentum is momentum before a collision or an explosion or a crash is equal to the momentum after a collision or an explosion or a crash, because momentum is conserved, we say. So you can use this to then work out maybe the speed of an object after a collision or a crash, okay? It's just a case of doing a bit of maths. There is a video on this as well if you have a look. Kinetic energy and gravitational potential energy didn't come up last year, can be big questions as well. Kinetic energy is anything that's moving, measured in joules. The reason why it's EK is because it's energy kinetic. It's equal to half, which is just 0.5, times mass times the velocity squared. Okay, don't get fooled by this. You need to square your velocity before you do anything. And if you're finding the velocity, you'll need to square root the answer that you find before that. The rule for this, though, is loss of gravitational potential energy is equal to the gain in kinetic, with no external factors, because obviously other external factors do apply, but we assume there's no external factors. So for example, gravitational potential energy, GPE, is also measured in joules. The formula for this is EP, so energy potential, equals mass times gravitational field strength times the height. Now, if you have a look here, as I said, if a person had a ball on top of a hill, and say that you've worked out the gravitational potential energy and it's 10, it's not moving, so the kinetic energy is 0. As that ball starts to fall, as it gets halfway, half of that gravitational potential energy has been converted into kinetic. Right before it hits the ground, it has 0 gravitational potential energy, and it has transferred that in an ideal environment to all of its kinetic. So for example, you might work out the gravitational potential energy at the top for an object, and then it might ask you what is the possible fastest speed of the object. So then you'd have to use this equation. You'd have to find out v. So you would already know your ek from what you had it at. Half times whatever the object's mass was. Bring that down divided by that, and then you'd square root this to get your v. Hope that helped.